Hello, still on our class on the fundamental theorem of calculus. And if you look at the board, I have 10 questions on the board, which we'll try to solve today. It says we should evaluate the ddx of the integral of the square root of 1 plus 3t dt from 0 to x. But when I see a question like this, what comes to my mind? Immediately what should come to my mind is the second fundamental theorem of calculus, FTC2. The second fundamental theorem of calculus, the second version. And what does the theorem say? It says if f of x is continuous on the closed interval ab, and a new function capital F of x, which is the antiderivative of this, is defined such that capital F of x is equal to the integral of f of t dt over the interval a to x. And if this is also continuous, if it is continuous on our interval AB and differentiable on the open interval AB, then it means that the differential of capital F of x, which is equal to d dx of the integral of f of t dt from a to x, and that is equal to what? F of x. Take note of this. From a constant a to what? The variable x. It must be a constant. It must be a constant for this rule, for this formula to be applicable. It must be what? It must be a constant. The lower limit of the integral, or the lower bound of the integral must be what? Must be a constant. Must be a constant for this to come into play. Now, using this to solve our question, the first one, d dx of the integral from 0 to x of the square root of 1 plus 3t dt. If I put this into this directly, my f of t is what? The square root of 1 plus 3t. My a is a constant, and that is 0. And therefore, it tells me that this d dx from integral 0 to x of 1 plus 3t dt will give me what? The square root of 1 plus 3x. Straight away, because that is my f of t. Just input your x back there and you have f of x. Let's look at the second one. Permit me to rub this off again because I don't want to rub off my questions. You can pause the video if you need to take a look at it again. And I don't want to rub off the second fundamental theorem which we are using. Number 2, we want to evaluate the d dx of the integral of cos t squared dt from 3 to x. Again, looking at it, it is from a constant. My a is 3, a constant. That is very important for me to make use of what? For me to make use of the second fundamental theorem of calculus. In this case again, my f of t is what? Cos t squared. And so it implies that d dx of the integral of cos t squared dt from 3 to x will be what? Will be cos x squared. Straight away. Isn't that simple? Simple. We are going to the third one. Again, permit me to rub that off. If you need to pause the video, you can go ahead and do that, so you can take a look at it. Yes, still on question number 3. Permit me to rub this off and then move this up there, so we can have enough space to work with down below. The differential of f of x is equal to d dx of the integral of f of t dt from the constant a to the variable x, and that is f of x. That's our second version of the fundamental theorem of calculus. I said previously that we should take note that this must be a constant. We should take note of this, and our a must be a constant. A must be a constant. We are solving question number 3. Question number 3 says you should take the d dx of the integral from 1 to 3x of the square root of 1 plus t squared dt. Again, I can see that my a is equal to 1, so my a is a constant, but my x is not just a variable, but rather is a function. So this will require me to do something like the chain rule. But before we get into that, I know that my f of t is what? The square root of 1 plus t dt. You will remember the chain rule. D dx is equal to d du times du dx. So do something like that there. Let's see how we go about it. Let's see how we go about it. Let u equals to 3x. If u is 3x, then our du dx is equal to 3. If du dx is equal to 3, that means that what? D dx of all of this will now become what? Let's try to make it simpler. D dx of the integral of 1 to 3x square root of 1 plus t squared dt will be equal to d du of the integral from 1 to u of the square root of 1 plus t squared dt times what? Du dx. I think it's making some sense there. 1 plus t squared. Now my u is a variable, not a function like this. It's just u. And so du of this will be what? Remember we said the integral differential of this is f of x. And so we said just put x into the function. For this, we just put u into the function. And that I have square root of 1 plus u squared times, what's our du dx? Our du dx is 3. So that gives us 3 into the square root of 1 plus u squared. But remember that our u squared is what? 3. Our u is 3x. And so that gives us 3 into the square root of 1 plus 9x squared. I hope you get that. You can pause the video and take a look at it again. Let's go to the fourth one. Let's go to the fourth one and see what happens there. Question number 4. They are taking the differential of the integral of t cubed sine t dt from 3 to 5x. Again, as we did before, remember I said that this must be a constant, as we have seen that our a is a constant 3. But instead of just having x up here, we have a function of x, and that's our 5x. But our f of t still remains as what? T cubed sine t. That's our f of t. If that is f of t, remember I said that we are going to perform something like the chain rule. And if we are performing something like the chain rule, it means that, let's write the chain rule again. D dx will be equals to d du times du dx. Now let u equals to 5x. If u is 5x, then du dx is equal to 5. And if du dx is equal to 5, therefore d dx of the integral from 3 to 5x of t cubed sine t dt will be equals to d du. Remember, we are replacing our 5x with u. d du of the integral of t cubed sine t dt from 3 to u times du dx. Now we have just the variable u there, and then our FTC2 can come into place. And so this is equal to, we replace that with u, replacing that with u, we have u cubed sine u. What's our du dx? Our du dx is 5. So that gives us 5 into 5x raised to the power 3 sine 5x. Pause the video so you can take a look at it again. The fifth one, d dx of the integral from 3 to x cube of t raised to power 4 dt. Again, our f of t is t raised to power 4. What have we done in the previous one for number 3 and number 4? We said, remember, that the lower limit must be a constant, which is, but the upper limit must be a variable, not a function. But when we have a function, we replace that function by a variable. Let u equals x raised to power 3. And so our answer, d dx of the integral of t raised to power 4 dt from 3 to x cube will be what? Du dx times d du of the integral of t raised to power 4 dt from 3 to u. We have replaced our x cube with u. And what is du dx? Du dx of u is what? 3x squared times d du of this is our f of u. And that is u raised to power 4. F of t is what? T raised to power 4. So f of u also will be u raised to power 4. And that gives us 3x squared into, what's our u? X cubed all to power 4. And that is 3x squared into x to power 12. That gives us what? 3x to power 14. We will look at the next one and see how it goes. Question number 6. If you need to pause the video, you can pause it and take a look at it again. Question number 6. d dx of the integral from x to 5 of t squared dt. In this case, I have a switch where the lower limit is a variable and my upper limit is a constant. But I will remind myself of one of the properties of Riemann integral. And that property of Riemann integral permits me to switch this and introduce a negative. What do I mean by that? The integral from x to 5 of t squared dt is the same thing as the negative integral of t squared dt from 5 to x. And so d dx of the integral from x to 5 of t squared dt becomes what? Minus d dx of the integral from 5 to x of t squared dt. Now it's looking like something that my FTC2 can work on. Moving from a constant to the variable x. My f of x, or my f of t rather, is t squared. So I substitute straight, and that gives me minus what? Minus x squared. Minus x squared. We move on to the 7th one. If you need to pause the video, you can do that, so you can take a look at it again. And if you need to see the video on the properties of Riemann integral, you can do that, so you can be reminded of that property of Riemann integral. Moving to the 7th one. Again, we are told to evaluate d dx of the integral of ln t dt from x squared to 5 to 7, sorry. Now we take a flip using the properties of Riemann integral, just as we did earlier on for question number 6. We take a flip of that, and so this is equal to minus d dx of the integral of ln t dt from 7 to x raised to power 2. You'll be reminded from example 3 and 4 that we have done before that our upper limit should be a variable, not a function. But when it is a function, then we perform something like the chain rule, which is what we did for example 3 and example 4, and we will do that again. Minus d dx of the integral from 7 to x squared of ln t dt will be equals to du dx times what? Times minus d dx of the integral minus d du. Remember, we have said our u will be x squared from 7 to u of ln t dt, where u is what? U is x squared. If u is x squared, then du dx will be what? Du dx will be 2x. This is equal to 2x times minus d du of ln t. Our f of t is ln t. So our f of u now will be what? Minus ln u. Minus ln u. But our u is what? I said our u 2x times minus ln x squared. And I can rewrite that properly as minus 2x ln x squared. Therefore, d dx of the integral from x squared to 7 of ln t dt is equal to minus 2x. We go to question number 8. Question number 8, we are evaluating d dx of the integral from 4 to x of ln t dt. This is straightforward. A is our constant and a is 4. X is a variable, so simple. Therefore, f of t is ln t, and if f of t is ln t, it implies that our f of x is what? Ln x. Therefore, d dx of the integral from 4 to x of ln t dt is what? Ln x. If you need to pause the video, you can pause it so you can take a look at it again. We go to question number 9. We can see that applying the fundamental theorem of calculus, especially the fundamental theorem of calculus 2, so questions like this can be very simple. You can try your hands on it and see how much of it you understand. Question number 9. Given that g of x is this, we are told that g of x is the integral from 1 to x of t squared dt. We are told to find g prime of x. Finding g prime of x is just the same thing as saying finding the finding the differential of g of x. And it's just the same thing as saying finding d dx of the integral from 1 to x of t squared dt. And if you have been looking at the way we have been solving the examples up until now, I think you should be able to bring the answer to this out straight away, and that is what? X squared. I'll leave us with question 10, and let us try our answer on it, and we give the answer in the comment section. If you have benefited from this video, give it a thumbs up, like it, and share with your other colleagues so they too can benefit. Thank you, and God bless you. I see you in the next.